So fundamental theorem, right? We have to, first step, integrate antiderivative. So power rule, use it if you can. If you can't, use substitution, right? And then once you find the antiderivative, you evaluate it, right? Evaluate it, plug in the top bound, plug in the bottom bound, subtract your answers, and you're done. Okay? So number 7. Number 7 is a absolute value. Anytime you have absolute value, don't even try to use one of the rules. Don't even try to use power rule, use substitution. It just doesn't work with these guys. Okay? Because the bars just create issues with using rules. So the way I always do with absolute value is just graph it. Okay, graph it and do it that way. Draw a picture, because trust me, it's the easiest way to do these instead of dealing with the rules. Because does the rule apply? Because it's inside the brackets. Does it rule not apply? Don't even worry about that. So draw a picture from 0 to 5. One, two, three, four, 5. And just plug in 0, plug in 1, plug in 2, plug in 3. You can do it in your head because it's not very hard. Plug in 0, you get square root of, or absolute value of 4, which is 4. It's linear inside the brackets. It's actually a linear function. So it's got a slope of -2. So when you plug in 1, your answer is going to be 2. When you plug in 2, your answer is going to be 0. When you plug in 3, your answer is going to be -2. When you plug in 4, your answer is going to be -4. Or, yeah, -4. And then the last value you plug in is 5. When you plug in 5, you get -6. Okay, it's linear. So you always shade back towards the x-axis. So over here, I would shade above. Over here, I would shade below. And you have 2 triangles. One of them's positive, one of them's negative. Find the area of each, add them together, and you're done. So the area of the green is 2 by 4. So 2 times 4 divided by 2, which is 4. The area of the pink is 1, 2, 3 by 6. 3 times 6 divided by 2. That's going to be 9, -9, since it's underneath. Add them together, and you get -5. That's the easiest way to do it. What's that?
Is this supposed to be positive?
No, it's negative. This way. No, you're right. I graphed this wrong. I graphed it wrong. It should all be positive. Same area, but there shouldn't be anything underneath the x-axis. Because when I graph it, let's see. So when I plug in 3, I get -2, so the absolute value is +2. Plug in 3, or plug in 4, I get -4, so the absolute value is +4. Plug in 5, I get -6. The absolute value is +6. Yeah, this is what it's supposed to look like. Same size triangles, just instead they should all be above the x-axis because it's absolute value. Two, 3 by 6. 6 times 3 divided by 2, which is 9. 13. There we go. Okay. The easiest way to do those is just by graphing. That's just it, because it's just using rules is way too hard. Okay. All right, so let's look at number 8. I want you to try number 8 on your own. Give number 8 a shot. Do number 8. We did one trig yesterday. Very similar sign. Okay, give that one a shot. We'll go over it in a few minutes. Okay, so you have to use u substitution for this one because it's sine of 2x. If it was just sine of x, you wouldn't need to use u substitution. But sine of 2x. Another way to know if you're going to use u substitution, another way to tell if do I have to use u substitution, is if think back last semester. If we had this guy here, if I had this guy here, sine of 2x, would I need to use the chain rule to find derivative of sine of 2x? Yeah. If the answer is yeah, then you're probably going to need to use u substitution. That's a way to tell if you need to use it or not. So u is 2x. So you put 2x, derivative, divide by 2, plug everything back in. You get 1/2. So now I have to find the antiderivative of u, or of sine of u. The antiderivative, the derivative of sine is cosine. The antiderivative is going to be negative cosine. So negative cosine of u. And I have to evaluate it from pi over 4 to 0. Okay. So put u back in. So u is 2x. Evaluate it from pi over 4 to 0. Okay, so I'm going to plug in pi over 4. Negative 1/2 times cosine of 2 times pi over 4 minus negative 1/2 cosine of 2 times 0. Okay. 2 times pi over 4 is pi over 2. Negative 1/2 times cosine. This is actually pi, because these guys cancel out, pi over 2. So cosine of pi over 2. Where is it? Cosine pi over 2 is 0. So actually, this guy right here will just cancel out because it's 0. 0 times negative 1/2 is 0. And then 2 times 0 is 0. Cosine of 0 is 1 times negative 1/2 is negative 1/2. 0 minus a negative 1/2 is positive 1/2. Okay, again, most of the mistakes I see come right there. That stuff right there, that order of operation stuff. Okay, because up here, it's just u substitution. So make sure, just be careful with that when you're doing that. Okay, so I have a couple more problems since we have about 15 minutes or so. I want to give you just a couple more problems. Tomorrow I'm going to give you an assignment so you can do practice, but for right now, we don't really have time to do anything else. So I'm just going to give you a couple of practice problems, and let me know what you get. Okay, so find some space. If you can't, do it on a separate sheet of paper, notebook, just somewhere where you can practice. Okay, we're gonna do 1, 2, maybe 3 problems. Just good practice. Okay, so find some place, find some room somewhere. All right, so the answer is 2. The answer is 2. But I haven't finished my work yet, but that's the answer. So if you got 2, then you probably did it right. If not, I'm going to finish it right now. So you change power or change roots to powers. U was 2x plus 1. So now I have to find the antiderivative. So I'm going to move the 1/2 to the front and the 1. And I'm going to move this guy and this guy to the front. If I multiply them, they're just 1/2. Antiderivative of u to the 1/2 is u to the 1/2. Negative 1/2 would be positive 1/2. Divide by 1/2. When you divide by 1/2, you're just multiplying by 2. It's the same thing as multiplying by 2. And then evaluate it from 4 to 0. Well, 2 times 1/2 is just 1 whole. So I got to move back in my u. My u was 2x plus 1 to the 1/2, and I have to evaluate that from 4 to 0. So plug in 4, plug in 0, subtract your answers, you're done. So when I plug in 4, I get 9 to the 1/2 power minus, and then when I plug in 0, I get 1 to the 1/2 power. When I plug in 4 here, I get 8 plus 1, which is 9. When I plug in 0 here, I get 1. 0 plus 1, which is 1. 9 to the 1/2 power is the same as the square root of 9, 3. 1 to the 1/2 power is 1. Subtract them, and you get 2. Okay. All right. Okay, let's try another one. Let's try. Actually, let's try. Let me try another one like that. Okay. From -3 to 2, 9 over the 4th root of 3x plus 10. And the answer is 28. See if you can get that. So I rewrote it. First thing I did was rewrote it. 9 times 3x plus 10 to the negative 1/4 power. U was 3x plus 10. Du was 3. Dx, I multiplied the 9 times the 1/3 that I substituted back in. I got 3. did u sub or antiderivative for u to the negative 1/4. So that's 3/4 divided by 3/4, which is multiplying by 4/3. Now all I have to do is plug in 2, plug in -3, and get my answer. Okay, so if I plug in, let's see, 4 times 3x plus 10 to the 3/4 power minus 4 times 3x plus 10 to the 3/4 power. So I'm going to plug in a 2 and I'm plugging in a -3. So I get 4 times 16 to the 3/4 power. 4 times 1 to the 3/4 power. 3/4 means cube and find the 4th root in whatever order you want to do. Well, it's probably easier to find the 4th root first. The 4th root of 16 is 2. 2 cubed is 8. This guy is just going to be 1. So you get 32 minus 4, which is 28. Okay. All right, let me give you one more. One more will be done. Let me try one that doesn't have a root. That was example 10. Here's example 11. Now, do that. Let's see. Let's do this one. No, that one doesn't have bounds. Here we go. 0 to 2 x plus e to the x dx. All right, so this guy here has got a plus in the middle. So the first thing I would do is break them apart. Treat them as two separate problems instead of one big problem. You don't have to, but I think that's probably a little easier. So you do the first problem first, just x. So you find the antiderivative of x, which is 1/2 x squared. So this is going to be 1/2 x squared from 2 to 0. And then this guy, the antiderivative of e to the x is e to the x. So it's going to be e to the x from 2 to 0. So it's two mini problems. You just separate it into two mini problems. Plug in 2 for the first one. So I get 1/2 2 squared minus 1/2 0 squared. This one's just 0 because 0 squared is 0 times 1/2. So over here you get, what do you get? 4 times 1/2 is 2. And then over here, you're going to get e squared minus e to the 0. E squared is just e squared. E to the 0 is 1. Combine like terms. You get 1 plus e squared. So that one you didn't even need to use substitution. For e, the only time you really need to use e substitution is if the power is anything other than x plus 1, 2x, negative 3x, something like that. Then you would use u substitution for that guy. But it was just pretty standard e to the x. And then there was just addition between them. So separate them. If you have that, if you have a plus in the middle there, you can separate as long as there's nothing under here. If it's like this, then you can't do that. Or you could, but if there's like x plus 1 or something like that, then you can't do that. But if it's just that, you can separate them. Okay? All right, so we got 4 or 5 minutes left. So tomorrow, I'll let you guys work on the assignment. Okay, so I'll have the assignment ready for you guys so you guys can work on it.